Many developers have strong opinions about the use, and some might say overuse, of the repository design pattern. Let's consider some of the common arguments made about repositories. It's worth remembering that, like Bjorn Strustrup's famous quote about programming languages, there are two kinds of design patterns too. It's no surprise really that as the repository pattern grew in popularity, that there would be many complaints about when and how to implement it.
Here's one that really gets me. EF Core, the .NET ORM, which we're using in this course, has a built-in repository for its data access. It's called the DB context. I've heard and read comments from so many people who say, never use a repository on top of EF Core because it already has a repository built in. And then I hear others who say, you should always use a repository to interact with EF Core. I am not a fan of the words always and never. Maybe it's because I'm a Libra, who knows? So these strongly held opinions really frustrate me. What Steve and I want to do here is give you the information you need so that you can make educated decisions about when to use a repository and when to opt for something else.
Let's remember for a moment what repositories are and where they live in a domain-driven application. Repositories are abstractions. They're part of your domain model. They define the persistence operations the model will use. That's it. There's nothing in the domain model patterns produced through model-driven design espousing the use of Entity Framework or Hibernate or any other specific vendor tool for doing persistence. It doesn't even know if you're doing Java or .NET. It's meant to be totally abstract and just types.
The domain model should be persistence ignorant, and it shouldn't depend on implementation details.
Right. One of the things I really appreciate about DDD and the way it isolates domain expressions within a layered architecture is that it aligns perfectly with solid design principles like the dependency inversion principle.
You are a big fan of solid, Steve.
Guilty. In this case, in terms of solid, using an abstraction for persistence enables us to follow dependency inversion because we can define an abstraction in our domain model and then implement it in another project that depends on the domain model. We can also write our application and its user interface so that it depends on our persistence abstraction too, rather than on the implementation details. That's the heart of dependency inversion.
And that makes it easier to follow the interface segregation principle, which I also learned about from your solid course. This principle prefers smaller interfaces. So if your app is using a DB context directly, that is not a small interface. Along with DB context repository features, it exposes a lot of other functionality. Using an abstraction that limits what your app needs to do with regard to persistence makes for a much simpler design in our model, reducing complexity.
Right, in that way it's similar to the facade pattern because it lets us work with a much simpler view of what could otherwise be a potentially very complex and powerful persistence library.
So when we're following DDD, our domain model shouldn't know anything about EF Core or whatever APIs you're using for your data persistence. If our model requires persistence, like most do, we should define abstractions in the model that describe what our needs are without specifying how they're done.
Exactly. The abstraction defines what needs done. The specific implementation is all about how to do it.
And one really popular and powerful way to do persistence in .NET is with Entity Framework Core. And because it implements methods that map pretty closely to most common persistence abstractions, it's usually pretty easy to implement a particular abstraction with a class that calls into EF Core.
Definitely. EF Core works great for this in most of the apps I work on, but we should never couple it tightly to our domain model.
Exactly. The whole point of DDD is that we shouldn't be coupling our domain problems with our persistence problems. Another question I get all the time, and which I've discussed in some of my other Entity Framework courses, is whether repositories should return iQueryable. And yes, I do have my opinions on that.
Yes, this is another source of some debate. On the face of it, it sounds like it would be a great idea. Your most basic repository abstraction might not provide much in the way of complex filtering options, and you can avoid having to think about that sort of thing if you just return an iQueryable.
Right, because then any code that consumes an iQueryable can extend the expression, adding additional filters or projections to the query before it's actually executed. On the surface, it sounds pretty good, right?
Well, it turns out that a lot of query logic is actually business logic, and if you return an iQueryable, it has two not-so-good effects. It can leak a lot of the implementation details, so your application code's behavior changes significantly based on the implementation of the repository, and it tends to put the business rules for querying all over the application.
Let's say we have an MVC application with a controller. So that's the server-side logic of the UI layer, and it returns a view to the UI. The controller calls into a service to get its list of customers, and the service contains a customer repository interface. That repository calls into an infrastructure project, and the infrastructure project is where we're using EF Core and its DB context. But to limit what's exposed outside of the infrastructure project, there's a repository there as well. The repository in the service makes its calls to the repository in the infrastructure layer. It sounds like a lot of layers, but that's not a problem because we have reduced coupling and made a maintainable solution. The real problem here is where can we put our query logic in this example?
Well, obviously the repository, and it wouldn't be unusual for the method in the service to further modify the query. But since it's also returning an iQueryable, the controller action could further modify that same expression tree. And assuming the controller just passes that same iQueryable to the view, which we've both seen teams do, even the view could further refine the query. So is this a good thing or a bad thing?
Well, on the plus side, we'd get a lot of flexibility without having to write a lot of code for our repository. We're also able to tailor the data we need to the specific place it's used, and even modify the query from multiple steps in the app. At the same time, we get to reuse a simple repository interface everywhere in our app.
Right, but on the other hand, that query logic is now spread out everywhere. Every class that's adding query logic, in addition to whatever else it's doing, is now violating the single responsibility principle. Then there's separation of concerns. Query logic should be separate from other concerns in most of these classes.
And another problem I see a lot with this approach is confusion about when the actual query is executed and what runs on the database server versus in memory in the application.
Many developers will assume the query runs inside the repository, and the result they get back is from the data store. And of course that's true for most calls, but not necessarily for those that return iQueryable.
Right. The query will execute the first time any code tries to enumerate the result. That could happen inside the repository, but it could also happen in the service, or in the controller, or even in the view.
Yeah, I see that a lot. A related issue is that developers at any step of this process can add additional logic that may compile just fine, but then at runtime, when EF tries to interpret it, it blows up.
Anything you add to the query expression that Entity Framework doesn't know how to translate into SQL is likely to cause an exception, at least with recent versions of EF Core.
And it may be redundant at this point, but it's probably worth adding here that there's no encapsulation when you use this approach.
There is a way we can fix at least some of these issues, though. For example, instead of returning iQueryable, we can still create flexible repository methods by passing in predicates. Then, in the implementation, this predicate can be passed along to the DB context as its where expression, providing the necessary filter. If you're not familiar with the term predicate, but you've used the link where method, that's what the method takes as its parameter, which is why we're able to pass it right to the where clause.
That does help part of the problem. Where before the query could have been executed at any of these points, at least now we know that whatever comes back from the repository will be the in-memory result. The actual query is always executed in the repository itself. Of course, if the service takes in a predicate, it still means that any code anywhere in the system could be responsible for creating the query logic, with the possible exception of the view if it's just being passed an IEnumerable at this point.
Okay, so with predicates, they're still very flexible. but they're not as easy to build up from multiple locations in your application, especially compared to iQueryable. The rest of the good points still hold, though.
The only thing we've really changed on the bad side is confusion about when the query actually executes. Being a fan of solid and encapsulation and knowing some other patterns we'll share later in this module, I'm usually going to vote against this approach too.
Well, another way we tend to solve this conundrum is going the custom query route. We even suggested this as a tip earlier, but you can definitely take it too far. Every little change to a query means another method. Customer with orders, customers by shoe size. By shoe size? Customers by favorite Netflix show? Hey, you never know what problems your domain experts are going to share with you.
The problem with this approach, if it goes beyond one or two methods, is that you really start to feel the pain of the open-closed principle violation. Every time another custom query requirement comes in, you have to change the repository abstraction and all of its implementations. And the bigger the type gets, the more it violates the interface segregation principle too. The more complex your problem is, the more query methods you'll be adding to your solution. This can surely be an untenable situation, and we will show you some better alternatives a little later in this module.